I want to give you a concept and to help you draw a picture of what we're going to be doing as we're dividing fractions. Because dividing fractions shouldn't scare us at all. So let me try to draw a picture, although a pretty bad picture, but a picture nonetheless. I'm asking the question, I want to know what 4/5 divided by 1/10 is. And the way that I want you to think about that is we're asking how many 1/10 are there in 4/5? How many 1/10 are there in 4/5? So I took a large rectangle, divided it up into 5 sections, and I colored 4 of those sections completely in. From there, I divided the large rectangle into 1/10. So my question is how many of those 1/10 are colored in? How many of those 1/10 are part of the 4/5? And I would count. Here's a tenth. Looks like I have 8 small rectangles are colored in. 8 1/10 are colored in. So 4/5 divided by 1/10 equals 8. Now, an algorithm that we can do this fairly straightforward is such, where we'll take the first number, which is 4/5, and we'll multiply it by the next number's reciprocal. A reciprocal means you take a ratio and just invert it. So 1/10, its reciprocal is 10 once. And so I took a division problem, turned it into a multiplication problem, and we know how to do multiplication problems. Top times top, bottom times bottom. So I'll have a 4, which I'm going to factor down to a 2 times a 2. The 10 factors down to a 2 times a 5. 5 factors down to a 5. 1 factors down to a 1. Notice that I have a common factor in the numerator and denominator. So I kind of simplified before I worked the problem through. And 2 times 2 times 2 is 8. All over 1, which equals 8. Now, as a side note, I simplified before I continued. You're more than welcome to solve first, then simplify. Had you done that, and maybe you did, you had 4 times 10, which equals 40 divided by a 5. And then you worked that out and received an 8. So again, simplify, then work, or work, then simplify. Matter of preference. I like to work smarter, not harder. And if I can work with smaller numbers, my life is happy. Again, dividing fractions. Here's the picture. Here's what we're trying to do. The process, we can take a division problem, and rather than doing a division problem, we can multiply by its inverse, multiply by its reciprocal as we go through. And we turn a division problem into a multiplication problem. So let's look at a couple extra examples of what that could look like. So let's look at 2/3 divided by 7/15. Let's convert that to a multiplication problem. Multiply by its reciprocal. From there, we can multiply across, but I'm going to factor things down first as I do that. So I have a 2 times a 3 times a 5. Do you see the 15 in there? 3 times a 5. And on the denominator, 3 times a 7. I can see some factors that cancel out. 3 or factor out, the 3's factor out. And I'm left with a 2 times a 5 over a 7 equals 10/7. Another example, 3/4 divided by 5. Uh-oh. There's one of those numbers again that don't have a top or a bottom. What do I do? Well, let's rewrite it as 3/4 divided by, remember how we write a number by itself as a fraction? It becomes a 5 over a 1. Now from there, we can go ahead and multiply by its reciprocal. I changed division to a multiplication only if I was willing to change the 5 over 1 to the 1 over a 5. Then from there, top times top, bottom times bottom, and it looks like I'm left with a 3/20. I didn't see any common factors in this process, and so there's nothing to factor out, so I know 3/20 is my final solution and it's reduced down. Lastly, 4 3/4 divided by 1 1/2. What do you think we want to do first? Yeah, I think you're right. Let's change them into improper fractions. 4 3/4, 16. That becomes a 19/4 divided by 3/2. Invert and multiply, or multiply and invert, maybe is better. I can see I'm going to have some common factors here, so I'm going to deal with that first because I don't really know what 19 times 2 is. That's a big number. But I can rewrite this as 19, which is prime, 2 is prime, 4 does factor down to a 2 times a 2, and then I have the 3. I can see a common factor of a 2 and a 2, so I'm left with 19/6. Now, as we mentioned earlier, improper fractions are equivalent to their mixed numbers. They're not simplified, but sometimes based on the context of the problem, you may want to return to one. So in this one, the context of the problem started with mixed numbers, so I probably should, to make the people happy, return it to a mixed number. So a 19/6, 6 goes into 19 3 times, 3/6 makes an 18. I have a 1 left over, and so it looks like I have 3 and 1/6. So 19/6, it's improper fraction. 3 1/6, it's its mixed number. Both are equivalent and both are reduced.